So this is the final part of chapter 9 and ends off the whole topic on recursion. So let's get going on this. Now the last part is nothing new to you, but it is called compound interest investments with regular addition to the principal. So it's annuity investments. Suppose you have some money invested in an account that pays compound interest. To increase the rate at which your investment grows, you decide to add to your investment. So this is the difference now. We're adding to our investment by making additional payments on a regular basis. Now, most of these formulas that you've seen here are not new to you anyway. So modeling compound interest investments with regular additions to the principal. That's what you would have in your notes. So let R be the interest rate for the compounding period. Let D be the payment made. A recurrence relations that can be used to model the value of a compound interest investment Vn after n additional payments have been made is given by the VO being the principal and Vn plus 1 RVn plus D. You've seen this before where R is 1 plus little r on 100. Example. Nor plans to travel overseas when she finishes her VCE. She has already saved $1,200, so we know that VO is $1,200, and she thinks that she can save an additional $50 each month. So we're going to be adding $50 to the loan each month that she plans to add to her savings account. The account pays an interest rate 3% per annum, so the interest rate is 3% per annum, and it's compounding monthly, so we've got to divide that by 12 later on. So it says model this investment using a recurrence relation of the form. They've given that to us there. Easy, you've done this type of thing before. So we know that VO is 1200. Then we also have it compounding monthly, so 3% divided by 12, which is that one giving us 0.25%. Divide that by 100 and you get that, and then we add 1 to it to get big R, which is 1.0025. D is 50. So initially what you would write is your V of O equals 1200. That's wrong there. So V of O is 1200, then V of N plus 1 equals 1.0025 times V of N plus 50. And that's how you do that recurrence relation and modeled. Next one. So her investment can be modeled by this relation, which we've worked out before. It says, use your calculator to determine recursively. Again, guys, you've done this before, and then answer the set question. What will the value of her investment be after 1 year? So in order to do that, on your graphics calculator, 1200, enter. Then you do times, so you get your ANS now after you've done that, times 1.0025 plus 50, press enter, and then keep pressing enter until you have this up here. So after 3 additional payments, the value of Nor's investment is that one there after 3 payments, $1,359.40. So if you did that for 12 months, you'll find out that that is the amount after 1 year that Nor's investment is worth, $1,844.82. Right, amortization tables you've seen before, pretty much the same as what we did before, but putting it into a table. There's the payments made that she's made. Look at that. 12 months, that's what's in the account. And this works exactly the same way as what we did previously. So guys, that is explained to you right here. Interest earned equals interest rate per compounding period times the previous balance. And you can go through this by yourself. We've done this before. Don't forget that when we're using Financial Solver, I'll show you how to do this on the graphics calculator. Again, we get back to this picture. This table here is very important to have in your notes. Bank gives you money, it's a positive. You give bank money, it's a negative. Okay, so make sure you know that. We know that the present value, the payment, and the future value is based on what you have in that table. So let's have a look at a question on the graphics calculator. So let's have a look at using Financial Solver to do a compound interest investment with regular additions to the principal, known also as annuity investments. Lara invests $500,000 at 5.5% per annum compounding monthly. Lars, not Lara, by the way. He makes regular deposits of $500 per month into the account. What is the value of the investment after 5 years? So guys, it's compounding monthly. So straight away, what I would do is I'd go down to PPY, CPY and change that to 12 and 12. So we've got that done. That's done there. And now I'll go back up to the top and put this information in here. So under N, we've got it for 5.5% per annum, make regular payment for 5 years, and it's compounding monthly. So that would be 5 by 12, which is 60. So we put 60 into this one. So that one there would be 60. I always keep pressing enter for some reason. The interest rate is 5.5, so we put that into there. The present value, well, we've got $50,000 and we're going to give that to the bank because we're investing it. That's going to the bank. So that's going to be negative $500,000. I keep stuffing up the numbers. So that's 50,000, one more. That's 500,000 that goes into there. We're going to also give the bank 500. So that's going to be negative 500 here. So negative 500 goes into there. We're going to give that to the bank every single month. This calculator is a bit hard to work with because I'm using it on the computer. So that goes into there. We're done. We want to work out the future value after 5 years. This is what we want. Press enter in here. And the future value of the investment would be $692,292.30, 29.730 cents. So after 5 years, Lars's investment will be worth that amount there. Very straightforward. And guys, that is the final part of chapter 9, and it ends recursion, the part on recursion. So that means all of our core further mathematics is completed. All the core work is done. Our core work, don't forget, was statistics, which was the first 7 chapters. And then it was recursion and finance, which is chapters 8 and 9. So 1 to 7 was all about data analysis, and that's the compulsory units, as well as 8 and 9, which is this. We are complete. And you must have heard by now that the VCAA has dropped a module. So we will decide what our next module would be, and that will be our final module for VCE 12 Further Mathematics for the year. And hopefully you guys will do all of the work required. And at the moment, it's exercise 9G, all questions. And also, guys, don't forget the chapter 9 summary and chapter 9 review questions. We'll see you next week.